calculator, make sure your mode is rating mode. And then I want to make sure you have this window right here. This window is negative 2 pi, positive 2 pi, Harley. And the x scale is 5/4. And y min is negative 2, y max is positive 2, y scale is 1. Make sure you have that window. 5/4 for the x scale. Any questions?
Yeah. Oh wait, restart, I wasn't listening.
Then go to your y equals. Whoa. And you're going to put in sine of x. And you're going to hit graph.
Wait. Mine's not the same, so I'm going to go back to let's go to window real quick.
I want to talk generally about inverses. At the very first of the year, I think it was our first module, we talked about inverses. And I want you to see what you guys remember about inverses. What are some of the characteristics of inverses? Yeah. Inverse functions. Say that again?
The x and y coordinates.
Okay, so x and y coordinates switch. And another way of saying that is domain range switch, right? So when you look for an inverse, you just switch x and y and solve the line with an inverse function. Do you remember doing that? Okay. What other stuff did we learn about inverses? Yeah, we spent a whole module on inverses. Yeah, this is by far the longest one. Two other things we learned about inverses are really important. Something has to take place in order for a function to have an inverse.
It has to be a function.
Well, it has to be a function, first of all, but we already kind of said that. But for its inverse to be a function, what does it have to be? Pass the horizontal line test. Here we go. That's it.
What if it's like an equal line test?
We say when a function passes both the vertical and the horizontal line test, we say it's 1-to-1. Remember that?
Yeah.
In other words, for every x, there's one y, and for every y, there's one x. So it has to pass both the vertical and the horizontal line test. There's one other thing that we learned about the graphs of a function and its inverse. The reflections over something. Brendan. Yeah, reflections over the line y equals x. And those are the things that we need to know. So I want you to take a look at this sine function that we graphed on the calculator right here. Is it 1-to-1?
No.
Is it 1-to-1? Does it pass the horizontal line test?
No.
Absolutely not.
Absolutely not. Absolutely.
If you put a horizontal line, how many times does the horizontal line cross this?
4 times.
More than 4 times.
We don't know that.
An infinite number of times, right? Now, in the graph, in this window that we see, it crosses 4 times, but it crosses an infinite number of times. So it's not 1-to-1. So mathematicians restricted the domain of the sine function so that it becomes 1-to-1, so that it does pass the horizontal line test. Where do you think they would restrict it? Where to where? Okay, so Grant's saying from -2
to 2.
to 2. Except for each one of these marks isn't 2. What are they?
5/4.
They're 5/4.
5/4.
So what does that
say that?
-2 mark? No. It's how much? Negative
Like
5/2.
the whole thing is
So yeah, the whole thing's fine. So it goes from negative 5/2 to positive 5/2. Right there. In other words,
ID.
between those two, we have a graph right here that is 1-to-1. It passes the horizontal line test. Got it?
Yes.
Does it pass from here to here?
Yeah.
Okay, and you can continue going down the line. There's other places, but mathematicians chose between negative pi halves and positive pi halves to define the sine inverse. So let's say you have this function right here, y equals sine of x. Okay, and we have the function y equals sine inverse of x. We know that the sine inverse of x, well, let's go back to sine of x. We know that x can be any angle now. And let's put this in the context of the inverse. We know that x can be any angle between negative pi halves and positive pi halves. And we know that y, or the answer, can be any number between what and what? If you look at the y value, remember sine is defined to be the y value. Look on the unit circle over here. And look at the y values. What's the largest? What's the smallest y value you see? One and negative one. That's exactly right. So negative one, positive one is the answers to that. So if we take a sine inverse, remember you switch the domain and range. So now x is going to become, what is x going to be between now? 1 and negative 1. And what is y going to be between? Negative pi halves and positive pi halves. Now, I want to look at a unit circle, and since we have some people that are not here, and I need to show the unit circle on the board right here. So let me pull that up really quickly. Oh, you know what? Those of you who are close to the board can use the unit circle here on the whiteboard. Otherwise, this poster probably shows a little bit better. Those of you who want to look at the poster right here. Okay, so here we have a unit circle. And if I was to restrict the domain between negative pi halves and positive pi halves, you'll notice, where's pi halves?
It's about up one.
Okay, right up to the top, right up here. Okay, so here's pi halves right here. And where's negative pi halves?
Down at the bottom.
Okay, it says 3 pi halves down here, right? But we have to go backwards to get to negative pi halves. So we have to turn in this direction right here, in a clockwise direction, and that's the negative angles. And so pi 6, well, I'm going to leave it at that. So any angle, so what you need to know, I write this down, that sine inverses, the answers are always in the first or fourth quadrant, and you put it in your calculator. And if it's a negative number, it's going to be in the fourth quadrant, right?
Sine inverses are in
Sine inverses are in the first or fourth quadrant, and if it's in the fourth quadrant, it's going to be negative. So I'm going to quiz you a little bit right here. I am going to give you sine inverse of 1/2. Where is sine inverse of 1/2? So I'm going to go back to this other unit circle right here. Sine inverse of 1/2. Yeah. Sine inverse of 1/2. Where is sine inverse of 1/2? What angle is sine inverse of 1/2? Now keep in mind, what's the definition of sine, you guys?
It's the y value.
The y value. Okay? So remember that sine of an angle, theta, is equal to y over r. Well, on the unit circle, what is r? It's 1. So sine of theta equals y over 1, which is just y. So on the unit circle, the sine is the y coordinate. So if I'm asking you this question right here, what's this question right here? What's the sine inverse of 1/2? Like that right there. Then I look at this right here, and I find where the sine is 1/2. What angle has a sine of 1/2? Raise your hand when you know. All right, Thomas, what do you think?
30 degrees.
Okay, we're going to do everything in radians. So what is that angle in radians? 5/6. Okay, good. So this angle right here, 5/6, has a y value of 1/2. Flip it off the screen. There we go. Y value of 1/2. So the answer that question right there. Sine inverse of 1/2 is pi over 6. Okay, here's another one for you.
Wait, what?
Sine inverse of negative root 2 over 2. Sine inverse of negative root 2 over 2. And you know this one. Raise your hand. Sine inverse of negative root 2 over 2. Okay, Kyle, what do you think? Okay, Kyle said 5 pi fourths. Let me ask you this. Is 5 pi fourths between negative pi halves and positive pi halves?
It's 7 pi fourths.
Okay, what did you say, Kate?
7.
7 pi fourths. Now 7 pi fourths is, and by the way, let's go back to 5 pi fourths. Here's 5 pi fourths. This is what Kyle said. And he is right. At 5 pi fourths, the sine is square root 2 over 2. But we're defined between the first and fourth quadrant. Okay, now, someone said 7 pi over fourths. Is 7 pi fourths between negative pi halves and positive pi halves?
Yeah.
No.
Okay, well,
Because 7 pi fourths is bigger than pi halves.
Yeah, but it's down there.
You are right that it is this angle. It's an angle that's coterminal to that angle. What angle is it? Negative pi fourths. Remember, you guys, when we go into the fourth quadrant, we got to go in the negative direction. So that angle right there is a negative pi fourths. So, going back right here, the answer to this one is a negative pi fourths. Okay, next one. Sine inverse of root 3 over 2. And you know the answer to this one. Raise your hand. Sine inverse of root 3 over 2. Sine inverse of root 3 over 2. I need to know who knows. Raise your hand if you know. Gonna see who's understanding. Okay, Brendan, what do you say?
Yes.
Pi thirds. How many of you guys got pi thirds? Okay, that is right. Because that pi thirds right up here, you have a root 3 over 2. So, right here, we're going to write pi thirds. Let's do this one. Sine inverse of a negative 1. 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 Raise your hand if you know. We need to see who knows. Hey, Lynn. She said negative pi over 2. You guys agree with her?
No, I thought.
That is correct, because negative pi halves, I mean, the angle that has a sine of negative 1 is right down here. The y value is negative 1. But you have to go in the negative direction right there. So it's not 3 pi halves, it's negative pi halves. Everybody got that? Okay, so go back here. This is negative pi halves. Okay? Kind of get the idea? Okay, just remember, if it's, think about this, if y is negative, then it's got to be down in the fourth quadrant. You got to go in the negative direction to get there. If it's positive, that means y was a positive number, and you got to go up to the first quadrant to get the answer. Okay, I'm going to do the next one right here. Let's talk about the next equation. Everybody put in your calculator the cosine. Go back right here. Oh, wait, before we do that, I want to show you the sine inverse.
What's the window again?
Hit and second and sine. So sine inverse of x, and you're going to graph that. Notice how it goes like this. Notice that it's between negative 1 and positive 1 right there. And it's between negative pi halves and positive pi halves right here. The y's are. And they restrict this, so that's the right there is the sine inverse function if you graph your calculator. Any questions on that? Okay, go to window is this right here, negative 2 pi, positive 2 pi, x scaled pi fourths. Y min is negative 2, y max is positive 2. Haven't got that yet. Okay, let's put in the cosine function.
We're supposed to be rating.
Yeah, you should be in radians. Here's the cosine function. All right, I want you to discuss at your table, where can you restrict the domain of this? Because this is not one-to-one either. You can see the horizontal line will cross it more than once. Where would you restrict the domain to make this one one-to-one? And there's more than one place. In fact, there's 4 places on this graph. I want you to discuss it for a second. Go ahead.
We'll go first.
Okay, David.
0 to 4.
0 to 4. By 4, do you mean this notch right here?
Yeah.
0 to 5.
What is that?
0 to
Pi. Okay. So 0 to pi. 0 to pi is 1 area because you get this length right here. That will work. Okay. This table right here. Negative pi to 0 would work from here to here. Okay. That table back there. Where's another place? I'm going to go to this table right here. Where do you guys see? What? Say it again, guys. Pi to 2 pi. So from pi to 2 pi right there, it's going to be this one right here. Where's the last one, you guys? Okay, negative 2 pi, positive, or to negative pi. Right in this area right here. Okay? Now, if we say this one is 1, this is 2, or this area 3, and this is area 4, I want you guys to vote on it. Which one do you think mathematicians chose? Okay, everybody thinks it's number 1. Raise your hand. Okay. Which one do you think mathematicians chose so that when you put in your calculator, you're going to get answers between those 2 intervals? Everybody thinks interval 1. How about interval 2? Okay, got 3 people for interval 2. How about interval 3? Got a lot more takers for that. How about interval 4? It would be interval 3. Okay? We chose the positive interval right here. So between 0 and pi. So everybody write this down. Okay? Y equals sine of theta and y equals sine inverse of theta. Actually, I'm going to put x instead of theta. I'm going to put x. Okay? So x has to be an angle between 0 and pi. And y has to be between what and what? What's the answer have to be between?
0 and
No, that's
Negative
1 and 1. Okay, but if I switch those around, now x has to be between what and what? Negative 1 and 1. And y has to be between 0 and pi. In other words, my answer is going to, on inverses, my answer is the angle, right? I'm looking for the angle. So, by the way, look at the unit circle. We're going to pull the unit circle back up right here. Unit circle. Okay, on the unit circle, here's 0. Pi goes around right here. So which 2 quadrants are we going to which 2 quadrants is the cosine inverse always going to be in? 1 and 2. That's kind of nice, isn't it? Because it's in positive angles, no negative angles here on the cosine inverses. Everything's going to be positive. Got it? So we're going to quiz you a little bit right here. Now keep in mind that y equals, or not y equals cosine of x, just cosine of x is defined to be what? Or I should say cosine of theta. I'm going to put cosine of theta. Cosine of theta is defined to be? Thank you. X over r. Cosine is defined to be x over r. In other words, it's the x distance, not the y distance. So this time, we're looking at it this way. We're looking at the x distance. So if I have an angle that ends right here, this is the x, this is the y, and this is r. I'm looking at this x distance and this r distance. and we already know that r is 1 on the circle, so I'm really looking at the x distance. So if it's a positive x, it goes to the first quadrant. If it's a negative x, it goes to the second quadrant. So let's quiz you a little bit right here. Cosine inverse of negative root 3 over 2. When you have the answer for this, raise your hand. Cosine inverse of negative root 3 over 2. Okay, Nick, what do you think? 5, 5, 6 is the correct answer. Because look, at 5 pi over 6, if we look at this unit circle right here, 5 pi over 6 is right here, and its x value is negative root 3 over 2, right? It's in the second quadrant, which is in the inverse, one of the inverse quadrants. And you have that right there. Any questions there? Okay. Yeah, cosine inverse is in the first or second quadrant. Okay, let's do the next one. Cosine inverse of 1/2. Cosine inverse of 1/2. When you have this, raise your hand. Cosine inverse of 1/2. Maddie. Haley. Okay, pi over 3 is the correct answer. Okay, pi over 3 is the correct answer because the x value is 1/2 right there, right? So, we have pi over 3 in that one. Okay, next one. Cosine inverse of negative 1. When you got the answer to this one, raise your hand. Cosine inverse of negative 1. Thomas, what do you got? Pi. Because of pi, it's negative 1. Okay, I got the next one. Cosine inverse of 0.
Whoa.
Wow.
Cosine inverse of 0. You got to raise your hand.
I'm not sure.
Cosine inverse of 0. Cosine inverse of 0.
Pi over 2.
Pi over 2. Everybody got that?
Yeah.
The x value is negative right there. Okay, last one. Cosine inverse of 1. Cosine inverse of 1. Cosine inverse of 1. Harvey. Cosine inverse of 1. Where is the x value 1? Carly. Where's the x value 1? 2 pi. 2 pi is not between 0 and pi. Remember, cosine inverse has to be between 0 and pi.
That's right. That's right.
It's right, but it's not right. What's the answer, you guys? 0. You said 2 pi the first time. On all I heard you say that is
You know the answer, John.
only when she's answering math questions. All right. Okay. Any questions right here? Okay, we got it? Yeah? All right. So. Oh, I need to show you guys.
How to do our assignment.
I'll show you. One last thing here.
How do you do it when it's not these long numbers?
It's second cosine. Oh, whoops.
I have a quick question.
Cosine inverse.
Kyle has a legit
You
question.
guys see cosine inverse right here?
Yeah.
Because our we have this point right here, and this is the reflection of it going up like that. And it's a fraction of the line y equals x. It's not on a perfect 45-degree angle, here, I mean, it is, but because our graph is longer this way than this way, it kind of makes it, skewed, okay? All right, so, here we go. Everybody got your assignment, the back page of your assignment, yes? Okay, so, on the back of your assignment, what's the first one on the back side? What number is it?
12.
4 over 5.
No, what number is it?
12.
12. Problem 12? And it says sine of theta equals 4/5. Okay, so, there's going to be these kind of questions on your next test, so make sure you know how to answer them. Now, I want to read the directions. You'll notice that it says, use your calculator. And what you know about sine and cosine are positive, negative, and unit circle to find the two angles that are solutions to the equation. Make sure theta is always between 0 and 2 pi. So your answer always has to be between 0 and 2 pi. Got it? Now keep in mind, some sine inverses are not between 0 and 2 pi. Now, there's always going to be two answers to each one of these as well. Okay? So, first, now it says you will notice that your calculator will sometimes give you a negative angle. That is because the calculator is programmed to restrict the angle of rotation, so the inverse of the function is also a function. Remember with the sine inverse, we had to restrict it between negative pi halves and positive pi halves. Since the requested answers have been restricted to positive rotation, if the calculator gives you a negative angle of rotation, you will need to figure out the positive coterminal angle for the angle that your calculator has given you. You guys remember what a coterminal angle is? Let's review it really quickly. What is a coterminal angle?
The same angle, and
Same angle,
different direction.
different direction, same terminal side is what it means, right? It has the same terminal side. So if I have an angle like this, so let's say I have this angle right here. I have the initial side, and I have a terminal side right there. Okay, this angle right here that we turned to get that part is the same as if we turned all the way around the circle once and then went to there, right? Or if we turned in the negative direction all the way around right there. All three of those angles are coterminal angles.
That's it. It's not mine.
So, coterminal angles, there's three. Now, there's more than three, actually. There's a lot of them. So, if I want to find 4/5, everybody take your calculator, and you're going to take and find, how am I going to find what theta is if sine of theta equals 4/5? What do I do? Okay, everybody, we're going to use a calculator to find do sine inverse of 4/5. Okay, if you're in radians, you should get 0.92. Is that round to the nearest hundred? 927. Okay, so 93. Okay, so 0.93 radians. Now, I want you to think about where 0.93 radians is. So, I want you to take pi 4. Go pi divided by 4 in your calculator. Tell me what you get. Point what?
79.
0.79? So 0.93 is more than that. Let's go to pi thirds. Take pi thirds and divide it. What is that one? Point? So pi divided by 3 is what?
1.05.
1.05? Okay, so 0.92 is somewhere in between. They're close to 1.05, right? Okay, so the angle of rotation is this angle right here. Okay, that's blue angle right here. I rotated that far. Now, it wants to know, so there's one of my answers. 0.93 is one of my answers. We're doing it in radians. So it's 0.93 radians. Now, you guys keep in mind, sine, when we did this problem, sine was y, which was 4, over r, which was 5, right? Where else on the unit circle is going to have a y value of 4 and an r value of 5? No, I mean, where else on the circle? Which quadrant, I should ask? First.
Third.
Well, we're already in the first quadrant.
Second.
The second quadrant, right here. Okay, the y value could be 4 and that could be 5. That would get you to that point, wouldn't it?
Yes.
The question is we need to know the angle of rotation from here to here. So we gotta know from the initial sides right here, what is that angle of rotation? How am I going to find it? Because my calculator, when I did sine inverse, only gave me 0.93. So I gotta be able to find this angle right here.
Subtract it from 260.
From pi,
From 2 pi.
From pi. Subtract it from pi, right? Why pi?
because that's the other side.
Yeah, guys, this angle going up from pi, right there, is 0.93. So if I take pi, go all the way around to pi, and subtract 0.93, I'm going to end up right here. Okay, so everybody take pi minus 0.93. What do you get? 2.21. There's your other answer. So 0.93 radians and 2.21 radians is going to get you there. Keep in mind, pi is 3.14 radians, so that makes sense, doesn't it?
So what happens if we get a negative?
Okay. Well, I want you to do. We're going to do 14 together right now. So everybody go to 14. What does that one say? Sine of theta equals what? Negative 1/10. Now, I want you to think about this. If I have a circle right here, and my y value is -1 and my r value is 10, that would be right down here, wouldn't it? So -1 and positive 10. We don't really care what the x value is. I need to know the angle I turn. So use your calculator. Where do you put your calculator to find this one?
Negative 0.1.
Well, sine inverse of -1/10. What do you get?
Negative 1/10.
Negative 0.1, right? Negative 0.1. There's a problem with that answer. What's the problem with that answer?
Negative.
It's negative. What are my answers supposed to be between? 0 to 2 pi. 0 to 2 pi are all positive numbers, so there's no answer that can be a negative. But I know there's two answers to this. I know one of my answers has got to be the angle that's coterminal to this angle, right? That's positive. I have to go clear around this way. So what am I going to do? Add 2 pi. Negative 0.1 plus 2 pi, because I got to go all the way around the circle from there. Remember, guys, coterminal angles differ by 2 pi. One full rotation, so 2 pi. So I add 2 pi. I'm going to get this angle right here. What is it? 6.18. 6.18. There's one of my angles. So I have to go clear around the circle back to 6.18. Well, now let's figure out which quadrant is my other angle in. Where else on here
1 and 4.
can you have a -1 y value and 10 as your r value? Which quadrant?
3.
The third quadrant, right here. Yeah.
I thought sine had to be in 1 and 4.
No, yeah, but look at this. Did you guys hear Thomas's question? Good question. He says, I thought this had to be in the first or fourth quadrant, right? Well, your initial answer when you put it in is going to be in that quadrant, but this question right here is not in sine inverse form. It's saying the sine of what angle is -1/10. Well, there's 1,000 angles. There's an infinite number of angles that have this -1/10.
Really?
Every angle coterminal of this one, the 6.18, is going to be coterminal to it, right? But my answer's got to be between 0 and 2 pi. In other words, I can have answers in these other quadrants because it's not asking me for the sine inverse. We use the sine inverse to find one of the answers to get this. But I'm trying to solve this equation right here. There's lots of different answers that will satisfy this equation. Okay, my other one is right here. If I go down 1 right here, -1, now 10 right here, that's another angle. But that angle goes from here around to here. How far is that? Or how do I find it? Say that again, Kai? 0.1 plus pi, yeah. Perfect. Because you go all the way to pi, plus you have to go 0.1, right? So pi plus 0.1, what do you get? 3.24. So my answers are 6.18 and 3.24. And notice when I put sine inverse in, I got -0.1, which it wasn't the answer I was looking for, but it helped me to find the answers.
So if we get a negative number, we add.
And if you get a sine inverse that's negative, yeah, you're going to add 2 pi. Well, then you're gonna take that number, you're gonna go pi plus that distance, but the positive of that distance. The other way you could do it is, no, that's the best way to do it. Okay? Everybody go to 16. What does 16 say now? Cosine of theta equals 11 divided by 12. Now we're talking about cosine. We're talking about x numbers, not y numbers. What does your calculator give you for this one? Cosine inverse. 0.41. What? The quadrant is 0.41 in radian. So 0.41 is down here somewhere, okay? Okay, my angle of rotation is 0.41. My radius is 12. And x is 11. We don't know what y is. We don't need to know what y is to figure this out. It's 0.41, right? Where else is going to have an x value of positive 11? Which quadrant? The fourth quadrant, yeah. So if we come down right here, you're going to go over 11 and then down whatever, but you know your r value is 12. So how do I find this angle of rotation right here? Minus it from 2 pi, yeah, because it's 2 pi go all the way around minus 0.41.
So it's put a negative before sign.
Say that again? Well, it's not the opposite.
Or you can say adding like. Can you
Yeah.
put a negative in
Well,
front?
in other words, if you go all the way around and then back off 0.41, you're going to end up right here, right? So 2 pi minus 0.41, what is it? 5.87?
Is it negative 0.41?
No. 0.41 was my answer up here, right?
And I got that for 1 here.
0.41 was this answer right up here.
So is there two possible answers?
Yeah, all of these have two possible answers, unless it's on an axis. An axis.
Wait, so you were?
Or you have to have both answers. Okay, go to 18. 18. What's this one? Cosine of theta equals what? Negative 7/8. What's your calculator say on this one, Carly? What?
Negative 7.
Say that again. 2.64. You guys learned that right?
Where
You gotta quit whispering back there, Carly. You talk normally, louder than that. 2.64. Did everybody get that there? Okay, so that angle, what quadrant is 2.64 in? Well, my x value is negative 7, right? My y value was, or my r value was 8, so negative 7 and 8. So I had to go to the left to get that, right? So, and I know sine inverse is defined in the first and second quadrant. So yeah, 2.64 is around right there. That's 2.64. Where else am I going to get a negative 7 for x? What other quadrant?
3.
Okay, third quadrant, right here, right?
Yeah.
Yep. Did you guys notice that cosines, they reflect over the x-axis and sines reflect over the y-axis?
Yeah.
There they are. So negative 7 and 8. How am I going to get that point right there? Because I want the angle that goes all the way around to right there. Well, here's the problem. If I add pi, because I'm right here right now, right at this spot, if I add pi, I'm going to end up down here.
I'd have to.
Maybe minus 2 pi equals.
Subtract 2 pi.
I said that.
If you go all the way around and you subtract the 2.64, you'll be back to right here. So 2 pi is minus 2.64.
I can do that.
You know what, Grant? You know this. You are just always talking, and so I learned to pick you out. And so when you say a right answer, I just think you're talking about something else. I don't know. I'm not trying to ignore you. try to ignore your other stuff.
I haven't been
Not your
hitting
right stuff.
stupid today.
Other than
Besides this,
yeah, I'm
mistake.
just swing that around, about kill somebody, and then you about died 2 times.
Hey, what point are you going for?
Hey, what's the answer? 2 pi minus 2.64. Huh? I can't hear you.
3.64.
3.64. No, you would add pi at 2.64. You would add one.
You're listening that?
This is the one.
Try to listen to him now.
Yeah, they're on the screen.
Okay. We got it? All right, I'm going to give you guys 4 minutes. Finish up this assignment. When you're done, go put it on the blackboard. How do you do that? Okay, so first page, tangent of theta is y over x. So number 1 is just y, which is 3 over 4, which is x. So 3/4, and so forth. Okay, turn it over. Okay, this is module 6.12 homework. Number 5 I'm going to let you do on your own, but I want you to look at 6, 7, 8, 9, 10, 11. Everybody find 6, 7, 8, 9, 10, 11. Look for them.
Looking at him.
Okay, notice that, so the left column is 6, 7, 8, 9, 10, 11. The right column is A, B, C, D, E, F. That's a matching one. You've got to match the ones on the left with the ones on the right. Keep in mind, there are 4 equations and 2 graphs that you have to match up with 4 equations and 2 graphs. That means equations are going to match up with equations. Are you kidding me? 2 of the equations are going to match up with 2 of the equations. Okay? So keep that in mind. Turn the page over. 12 and 13. You're supposed to match them with A, B, C, and D over on the right.
Is there only one that goes good?
I'll give you a hint. One of those, 12 and 13, has no match on the right, and one of them has only one match. So that's only one. Okay, 14, 15, and 16. Cross that out.
Yeah.
14, 15, and 16. Cross out. We're not going to do those.
16.
17 and 18.
I'll try to do it.
Let me give you 2 formulas, remember, that you need to know. Period is equal to 2 pi over k, because you have to find it. And horizontal shift, which is the same thing as phase shift, is equal to c over k. Remember, we studied that last week. So, find all that stuff. The phase shift is c over k. So horizontal shift is the same thing as phase shift, and it's c over k.
Yeah. G is what?
C, you have the equation y equals a sine
We have notes on it.
of k
Oh, yeah.
minus c plus h.
Oh, yeah.
H is the vertical shift, A is the amplitude, k affects the period,
Yeah.
Where's
C
Christian?
affects the horizontal shift, and C and K both affect the horizontal
Have
shift.
that.
Okay, turn it over. This is the page I want to do with you, right here. Okay, the rest of it I want you guys to do on your own, but I want to go to number 19.
You ready now?
Okay, number 19. Do you guys remember compositions of functions, first of all? You guys remember if you have f composed of g of x? Raise your hand if you remember doing this stuff last year. F composed of g of x. The other way you can write that is f of g of x. Do you remember that?
Why?
Okay. Nick? You remember doing this stuff? Okay. So if I had something like f of x equals 2x plus 1, and g of x equals 3x minus 2, how do I find f composed of g of x? Which one do I put in which one?
G in the.
Yeah, you're going to put g in for x. You're going to put this whole thing in for that x. So 2 times 3x minus 2 plus 1. And you're going to simplify that to be 6x minus 3, right? Any questions on that? That's a composition of functions. Okay, now, go to number 19. We are going to do composition of functions with trig functions. So if I have the sine of the sine inverse of root 2 over 2. The sine of the sine inverse of root 2 over 2. I'm going to do the inside function first. This is a composition of functions. What's the sine inverse of root 2 over 2? In other words, what angle has a sine of root 2 over 2? Okay, pi fourths does. So I'm going to replace that with pi fourths. What is the sine of pi fourths? Square root 2 over 2. I don't know if you guys noticed this, but the sine inverse of root 2 over 2 is root 2 over 2 is cancelled.
So, yeah, that's what I was gonna say.
Anytime you're taking a sine and sine inverse, a cosine and cosine inverse, or a tangent and tangent inverse, they're going to cancel each other out. Look at 19, 20, and 21. Are those types of questions?
Indeed they are.
So you should have 19, 20, and 21 done. You got them? Okay, go to 22. What's different about 22?
I think of sine, cos.
Yeah, it's not sine and sine or cosine and cosine, it's sine and cosine. So sine of the cosine inverse of 1/2. Okay, I can do this the same way as this. So what's the cosine inverse of 1/2? Well, yeah, if you look at pi thirds, its x value is 1/2, right? So pi thirds is the inside answer, so sine, and we're going to replace the cosine inverse 1/2 with pi thirds. Now, what is the sine of pi thirds?
Root 3 over 2.
Root 3 over 2. There's your answer. Got it?
Yeah.
Now, let me ask you this. On number 23, guys, how do you get the tangent inverse of 1? What angle has a tangent of 1?
45 degrees.
45 degree or pi over 4. Because tangent you find to be y over x.
Yeah.
That's the only place where both coordinates are the same. So if you divide a coordinate by itself, it's going to be 1, right? So the answer to 23, you have the tangent inverse of 1 is pi fourths, and then you got to take the cosine of pi fourths, which is root 2 over 2. Okay, everybody go to 24. Sine of the tangent inverse of 2.75. This one, just use your calculator. Tangent inverse of 2.75. Now, okay, now take the sine of that. 9.3? 0.93. Right. 0.93 radians, right? No, 0.93. 0.94. Okay. Everybody go to 28. 28. You have the sine of the tangent inverse of undefined. That seems really weird.
So we just keep it undefined.
Think about this. Well, how is the tangent going to be undefined? How do you make a number undefined? Divided by 0. Keep in mind, tangent is y over x. So what has to be 0? X. Where is the x 0? Pi halves. Everybody look at pi halves. Pi halves coordinates are 0, 1, right? So tangent of an angle is y over x. So 1 over 0 is undefined. So tangent inverse, where is the tangent inverse undefined? At pi halves. So now you're going to take the sine of pi halves. What's the sine of pi halves? 1. Sine of pi halves is the y value, which is 1. Okay. All right. This time, let's do next time. Use the rest of the class to finish it up.